Then welcome back. Let us go through the statistical analysis problem. And this problem is related to an installation of a camera designed to catch cars that go through the red light. The goal of this example is to determine if the camera reduces the number of red light runners. Yeah, so let's go through the example. So question 2, it reads, in a preliminary study to determine whether the installation of a camera designed to catch cars that go through red lights affects the number of violators. The number of red light runners were recorded for each day of the week before and after the camera was installed using the following statistics, both represented by the first statistics and after represented by the second statistics. Can we infer that the camera reduces the number of red light runners? Okay, so we are given sample size number 1 to be 7, sample size mean x1 given 19, sample standard deviation as 1 given to be 43.33. We are given for the after period sample size n 2 to be 7 as well, sample mean x2 to be 17.14, sample standard deviation as 2 to be 20.48. Just to remind you, the before is represented using 1 and the after is represented using number 2. Okay, so to answer the question whether the camera reduces the number of red light runners, we will have to start by performing a hypothesis. So for our hypothesis testing, let us firstly say the null hypothesis assumes equal variances, and the alternative hypothesis assume unequal variances. Using the formula f value, we will say the standard deviation squared for before over the standard deviation squared for after should give us 4.48, and let us take that as our f value. Next, we find the critical f value using the f distribution function with the alpha of 0.05 and a degree of freedom df1 and df2 being sample size minus 1, and that will be 6 for each. So if we solve the f critical using Excel, just put that formula there as it is, you should get 4.28. In conclusion, we can say that since the calculated f value 4.48 is greater than the critical f value 4.28, we fail to reject the null hypothesis, indicating no evidence to suggest that the variances differ. Now, this means that we are going to apply the variances test, t-test. Let's proceed. Moving along to the t-test, let's do our hypothesis again. So our null hypothesis assumes equal means, while the alternative hypothesis assumes unequal means. Let us assume a significance level of 0.5, else we could have also calculated it as the 0.5 corresponds to the 95% level of confidence. The test statistics is calculated using this formula over here. If we substitute the mean for before and after, the standard deviation for before and after, and the sample size for before and after, we should get 0.103. Now that we have the t-test statistical, let's also get the critical t-test. For our critical t-value, we are going to use Excel. Substitute this formula here. If you substitute this onto your Excel, you should get 2.447 for your critical value. To find the p-value, we calculate it to be 2 times that of our alpha, and that should give us 0.1. Using the t-distribution function on Excel, we can calculate this p-value over here, and it was found to be 0.46. Now let's conclude, but first let's compare the t-values. We are going to say that the calculated t-value gave us 0.103 versus that of the critical value was 2.47. So the critical t-value was greater than that of the calculated t-value. Since the calculated t-value is less than that of the critical, we can also look at the p-value. Based on the p-value, we can see that the p-value is also higher than that of alpha. Therefore, we fail to reject the null hypothesis, suggesting we do not have enough evidence that the camera reduces the number of red light runners.